All right, so let's talk about ODP 418 first of all, because I saw a lot of excitement about that. So the goal was to take an input string and move the first character to the last position and shift everything else over to the left. And I saw lots of emails and comments from people saying my code works, but it's giving me 0 out of 10. So my code works can mean a lot of things, right? Your code compiles, right? That's essential for it to work, but that's not sufficient. Lots of code will compile. Your code does the right thing on your test case. That's another requirement, but it's not sufficient. You ran 5 different test cases and it works in all those cases. It's still possible that your code is not completely right. So remember, I mentioned 3 cases to worry about. The general case, big long string. The case where your string is empty, which is kind of always an edge case. And in this case, a string with just a single character is also an edge case. Right, so I said try those 2 edge cases and the general case. And here's some code that looks fairly reasonable, but actually does not work. I save the first character, so the top is just test code. So here's the function I would actually assess, right? And what does it do? Well, there's an input array called in, there's an output array called out. I is a temporary pointer, so first thing I do is I save the first character in this other temporary variable called save, and then I march through from 0 to string length of in, and I copy out I from in I plus 1. That moves everything down 1 spot, right? So the B goes into A and C goes into B and so on. And then if the array had any characters in it at all, in other words, if I is bigger than 0, then I copy that save character into the last position in the array. And then I throw on a null terminator. So I'm going to test this as follows. I'm going to have an output array called out, big enough to hold 100 spots. I'm going to call move. My first argument, I'm just going to pass A, B, C, D, E. And my second argument, I'm going to use the name of this output array, which is writable. And then I'm going to print the value of out, and I'm going to put it in angle brackets and make sure that works. And I should prototype my function. So integer move. Car star, car star. And I'll run that, and it looks like it's doing the right thing. A, B, C, D, E turned into B, C, D, E, A. So the other suggestion I made to you yesterday was assume that your output array starts with a bunch of question marks, but I didn't actually tell you how to do that. So what do I mean by that? Right now, who knows what's in this array out? We haven't declared it. We know that our move function is going to populate that array, but let's be explicit, and let's do something like string copy into out, bunch of question marks. And that shouldn't stop our code from working. But in fact, if you do that, you find this extra question mark sitting there at the end. That tells you something really big right there, right? That question mark probably came from what was originally in the output array. And the reason it's still there is probably I moved the null terminator into the wrong position. I put it after that first question mark instead of the spot that I actually wanted it in. And if you work through your logic, go ahead and set up your array to be something shorter to work with. Here's what we'll do. So let me just copy this code over. So integer I, car save equals in bracket 0. For I equals 0, I less than string length of in I++, out bracket I equals in bracket I plus 1. If I bigger than 0, out bracket I minus 1 equals save, out bracket I plus 1 equals null terminator. Okay, so here's some sloppily written code. And let's just try calling this with in equal to A, B, C, followed by the null terminator. And let's set out equal to a bunch of question marks, followed by the null terminator. And let's run this code by hand. So we call move, right? So in gets whatever we passed in. Out is whatever we passed in for out. It's just initially stuff. I is an integer, but we haven't given it a value. So that could be anything. Save is a character, but when we declare save, we actually initialize it to in bracket 0. Well, in bracket 0 is the letter A. Okay, now we say for I equals 0, and I is less than string length of in. So what's string length of in? 3, right? Be clear about that. It's 3 characters. It does not count the terminator. So for I equals 0, I less than 3. So I equals 0, and this says out bracket 0 equals in bracket 1. Well, in bracket 1 is the B, so out bracket 0 is going to be a B. And we go back to the loop. I gets incremented to a 1. It's still less than 3. Out bracket 1 equals in bracket 2. In bracket 0, 1, 2 is a C. Out bracket 1 becomes a C. Good. I gets incremented again to a 2. It's still less than 3. Out bracket 2 equals in bracket 3. In bracket 3, 0, 1, 2, 3 is a null terminator. Out bracket 2 gets changed to a null terminator. Not bad. I gets incremented to 3. 3 is not less than 3, so we exit the for loop. If I is bigger than 0, well, it is because it's 3. Out bracket I minus 1 equals save. I is equal to 3. Out bracket 2 equals save. 0, 1, 2, that's this. Gets set equal to save. That's an A. Last statement, out bracket I plus 1 equals null. I is equal to 3. Out bracket 4 gets set to a null terminator. 0, 1, 2, 3, 4. This becomes a null terminator. And now out is equal to B, C, A, question mark, and a null terminator, which is exactly what it showed us when we ran it. So a couple of things here, right? One is testing edge cases, right? Empty strings, short strings, regular strings. The other is don't assume that your variables have any particular initial value, and you can force that by, for example, I could initialize I to be, I don't know, negative 5,000. I can initialize my output array to be a bunch of question marks. And if your code seems to be doing something odd, right, trace through it by hand like this, and convince yourself that this code is doing exactly what it should do, right? And that will help you understand what this code means, right? Even if it's not what you wanted the outcome to be, it's still a good way to get practice with this. With strings, there's an oddity. So I could not do this, right? That makes no sense because I'm not passing out to it, right? I'm not passing any variable that can be changed. And I might try to do this, but in the way this compiler is set up, if I define a character array with double quote some bunch of stuff, that gets put into memory in a place that can't be written. And so when my move function tries to modify the elements of that array, I'll get a seg fault. right? So technically this is logically this is fine, right? Out as a character array that's initialized to that, but I think I'll actually segfault when I try to modify it. Maybe not. Yeah. And that's just something you have to realize and remember. So then after you do this analysis, right, you say, okay, where did I want to put the null terminator? I wanted to put it in position 0, 1, 2. I wanted it in element 3. Well, that was the value of I. This probably should have just been out bracket I. So now you go ahead and you change that, and it looks like it works, and that would assess well. All right, so 419, we're doing something different from strings. We're working with something totally new here, something that I call stateful programming, basically dealing with flags of a sort. So 419, you're writing two functions. One is called put, one is called get. Okay, very simple behavior. Put takes an integer argument, and it sticks it somewhere in memory so it can get it back later. And get simply gets that value that you put and returns it. So put, put returns a 0 for no particular reason. So put, so here's an example of this. Suppose I say, this is my main program. Suppose I say put 5, and then I say I equals get. I should be equal to 5. That's all it does. Now if I put 7 and then I put 25 and I say I equals get, I should be equal to 25. And if I say I equals get again, I is equal to 25, or maybe I2 equals get, I2 will be 25. There's nothing fancy going on here. Anytime you call put, this value gets saved somewhere, and when you call get, it just returns that value. And there's no deeper memory. If I call put 15 times, whatever the last value is that I put, that's what get's going to always return. And I can call get 100 times, it'll just return that same value. So if you know what a stack is, this is not a stack. This is just one value that we save by calling put, and we can retrieve by calling get. So everybody clear what the intended behavior is? Right, get just returns the value that was most recently saved by put. And so to do this, you need some kind of global variable. So here's our integer get. And here's our function integer put. Maybe it takes an integer n. Right, so this is all going inside a file called putget.c. Okay, so how do globals work in C? If you declare a variable inside these curly brackets, it's local to this function. If you declare it inside these curly brackets, it's local to this function. If you declare a variable outside of your functions, it's basically global. It has a value that can be accessed by any function from that point down. So if I say something like integer save, and I declare it before I start this function, inside here, if I try to use the variable save, it's referring to that variable. Inside here, if I try to refer to the variable save, it's referring to that same variable. So what do you want to do? Well, in your put function, just set save equal to n. In your get function, just return save. Okay, so it's really just a few lines of code. But it's a different idea, right? Usually functions are kind of self-contained things. You pass stuff to them, they do things, they return a value back to you, and that's the end of it. this function put has what we could think of as a side effect. It sets some value somewhere in memory that later on a totally different function named get can access and return to us. And this can be useful in different ways in programming. So two functions, put and get. Put them both in a file called putget.c. Test it out with a main program, right? Call put, call get, see what it returns. Link it with the test bed, assess it. And there shouldn't be any really weird cases to worry about here. I'm not going to call get until I call put, so it doesn't matter what the initial value of this variable is. The proper usage of this is you only call get after you've called put. Right, so I'm going to put something into memory and then I'm going to retrieve it with getchar. Does that make sense? Did I post a copy of PA4 as executable on the server?
No.
I didn't? Is there a reason not to? Oh yeah, index sample. Okay. All right. So here's the sample executable for PA4, right? So it reads standard in and it generates this index. We know this behavior. So when you're reading from standard in, right, and you're typing in stuff, and you want to signify the end of file, what do? Control D, right? So hold down Control. It's got to be at the beginning of the line. Hold down Control, press D. I wasn't at the beginning of the line, and it you know, this was all one phrase, so we just found one phrase. So when you want to test this, it's a pain to keep typing this stuff in, right? And I gave you War and Peace as a sample file that you could work on. So when you run this, you can say less than and put in the name of a file, and you don't have to change your code, right? Your code is still reading from standard in, but this less than sign changes what standard in means. Normally standard in is your keyboard. If I say command less than the name of a file, suddenly standard in is coming from that file. So I could say /temp/index.sample less than, do I still have a move.c? Yeah. So now I can run my index program on my move code, and that's not very interesting, but you know. Right. And then the example was running on War and Peace. So your PA4 is always reading from standard in. Okay, don't worry about fopen and fgets and all of that kind of stuff. It's just going to read from standard in. And if you want to test it with input from a file, just use that less than sign. Is that clear? All right, so two things to make sure I mention about PA4, and I've mentioned these in the afternoon section, but not in here. One, do not read the entire input and store it into memory and then start trying to process it. Okay, your input could be terabytes of data, and your code should still be able to produce an index on it. So you don't want to pull everything in and save it into memory. Okay, that's a really hard way to do this. You also don't want to use fgets to read a line at a time. That's going to be really confusing to try to do. Really, you want to process your input one character at a time. And so this is a super duper getchar function that I keep mentioning that you want to write. So getchar will let you read a single character from standard in. And that's really all you need. Read a character, read a character, read a character. And as you read those characters, super duper getchar pre-processes them, turns them into nice uppercase things, right? And your code is building a phrase. It's reading a character, adding it to the end of a phrase, read the next character, add that to the end, and so on until it gets to the end of a phrase. And now it takes that chunk that it's built and it says, here's my phrase. And it goes and it consults the dictionary of phrases and either adds it as a new entry or updates the count if it's seen it before. And then it goes back to reading one character at a time. And now it's reading, the stuff between one phrase and the next, the space, the comma, the so on and so forth, until it finds the start of a phrase. And now it starts reading more characters from the input one at a time and saving them in a new phrase. And when it gets to, a period which ends that phrase, it takes that new thing, throws a delimiter on the end and says, here's my next phrase, and hands that to the dictionary processing code, and it updates the dictionary accordingly. So you can do this one character at a time, and it actually makes your life easier. If you do something like fgets and you read in 200 characters, now you got to break that up. And that is fundamentally a harder process. So let's play with getchar. So getchar is part of a bundle of functions along with fgets. And getchar is equivalent to getC standard in. GetC is equivalent to fgetC, except that it may be implemented as macro. So this is really just fgetC. FgetC reads the next character from, in this case, standard in, and returns it as an unsigned int, yes, to an integer, or EOF, an end of file or error. That's too many words to think about, so let's just write some code. So this will be test 1. Okay, first thing, getchar does not return a character. I know it's called getchar. It actually returns an integer. We'll talk about why in a second. So whatever I'm going to save getchar in, I need it to be an integer. Okay, getchar returns a value, so we can say something like C equals getchar, and that will give us the value that getchar found. So let's just print out as an integer, C is equal to, and we'll just print it out with a %D. And that's as fancy as I'm going to get for now, right? Because we're trying to figure out what this function is all about. So basically 2 lines of executable code. We'll call getchar, we'll see what it returns. Alright, so I'll go ahead and I'll run T1, and I'll say, hello, enter. Okay, as an integer, C equals 72. So any guesses what 72 is? Yeah, it's the ASCII code for an uppercase H. So if you only know one ASCII code, A is a good one to know. It's 65. So you could try this with like A, and it gives you back a 65. That's a handy one because if you can count on fingers and toes, you can get from A up to, at least the letter T by just bumping it up. And then if you add 32, you get to the lowercase letters, starting with lowercase a. Anyway, and whatever I type it seems like it's the first character that getchar is consuming and it's returning that value of 65. Okay, so what happens if I just hit enter? What do you think getchar is going to return? Say again? A new line. Any other guesses? How many people think the universe will collapse? Could happen. Okay, it returns a 10. 10 is a new line. 10 is actually Control J. J is the 10th letter of the alphabet. Control J is the old way that you used to do a new line. So that returns a new line. If I do a space, it returns a 32. 32 is the ASCII code for a space. If I do a tilde, that's a 126. That's the last printable ASCII character. If I do a Control A, that's ASCII code 1. So this is pretty reliably returning the ASCII code of whatever character I type in. Okay, with one exception. So I've said if you want to register end of file, you hit a Control D. So if I hold down Control and press D, C comes back with -1. Okay, -1 is not a valid ASCII code. ASCII codes go from 0 through 127 inclusive. -1 is a flag. It's a value that we never expect to get because it's not a legal ASCII code. What -1 means is I did not find an ASCII code, I found the end of the file. And so this business on the man page, fgetC reads the next character from stream, returns it as an unsigned character cast to an int, or EOF on end of file or error. So -1 is the way that EOF is coded. And we can see this. Let's just print out what EOF is as a %D. And EOF, uppercase 3 characters, is set up in standard.io.h. And if we print that out with a %C, %D, it tells us EOF has the value -1. So if we want to know if end of file occurred, right, here's what we can do. Right, if C equals EOF, we can print out I detected the end of the file. So if I hit Control D, it knows end of file happened. Well, now we have a way to know when input ends. So now we can do this in a loop. Well, let's not do that first. Let's do this. And let's get rid of this print because we know EOF is -1 now. But when you're looking for an end of file, don't use -1, use EOF. Okay? The reason that EOF is set up is that you don't want to code magic numbers because maybe on someone else's Linux system EOF is -2 and -20. Right? But EOF is always guaranteed to be the thing that getchar returns when you hit end of file. Right, so from the manual page, that's the thing you got to look for. And if you look for -1, you probably end up losing points. Maybe not from me, but from someone else, definitely. So look for EOF. Okay, so let's call getchar 5 times. And let's print the value that it returns each time. So let's go hello. it found the value 72, 69, 76, 76, 79. That's HELLO. Those two 76s are a giveaway. Same letter. Alright, if I just say ABC and hit enter, it tells me that it got 65, 66, 67, that's ABC, and then it got 10, which was the new line. And it didn't print a fifth line. Why? Because it's sitting inside getchar waiting for more input. And now if I hit, I don't know, the letter Z, and it tells me it found the character 90. Now if I run this and I hit Control D, it tells me it found end of file. Yeah?
So why ABC, that one will have a new line, will print out a new line, others don't have a new line?
So if I just did AB, that would show me the A and the B and the new line. Okay, so let's draw a picture of this, because this is less obvious than I'm making it seem. Suppose you type A, B, C, and enter. Right. Remember, we have this sort of holding area, this sort of pipeline that all of this stuff goes into. So this pipe contains an A, a B, a C. The enter translates to a new line. Right. And if I don't call getchar, if I say C equals getchar, what happens? The system goes off and it waits for stuff to appear in this pipe. Okay, so I type A, B, C. It's only once I hit the enter that getchar comes back from this call. Right? And it will say, okay, so what's the first thing in the pipe? It's an A, so it absorbs that and it returns the character A. Now if I call getchar again, right, first thing it does, it checks this pipe and says, is there anything in here? Yeah, there is. There's a B. So it returns that B. That's the next value. Call it again. It checks the pipe. Is there anything in the pipe? Yeah, there is. There's a C, so it gets that and returns that. Call it a fourth time. Is there anything in the pipe? Yeah, there's a new line, so it returns the new line. That was the 10. And then our code calls it one more time. And it checks the pipe, and the pipe is empty. So now it sits here and it waits for stuff to appear in this pipeline. And now if I type in D, E, G, F, and a new line, right, it's only once I hit the new line that this stuff goes into this pipeline. So now the pipeline contains D, E, G, F, and a new line. And this call getchar will now find that D, and it'll return the D. So when you type stuff on your keyboard, it's not immediately available to getchar, right? Which is why you can type stuff and you can go back and delete it. When you type stuff on your keyboard, it's going into kind of a holding area, and you can go back and delete it and so on and so forth. Once you hit enter, everything that you typed goes into this pipeline, which we can think of as standard in. And so if your first call to getchar was found an empty pipeline, it's basically waiting for stuff to appear in here, and whatever you typed in will go into the pipe. But I can type stuff and I can go back and I can change my mind. And it's only when I hit enter that whatever I ended up with on that line goes into standard in and now gets absorbed by getchar. So getchar is reading the first two characters and now it's waiting for more stuff in the pipe.
So when you type hello, why it doesn't have a new line there?
Because I'm only calling getchar 5 times. I spelled it wrong though. Right, so when I typed in hello, what went into my pipe? HELLO and a new line. And my first call 5 to getchar is picked off the HELLO. And the new line is still sitting there. So if I call getchar a 6th time, I'll see the new line. And if I call it a 7th time, my code will block. It will wait until things appear in there. and this is a concept that'll be critical in 223, so we've got time to talk about it. But this idea of a call blocking. When you call getchar, if there's nothing available to read, you're stuck inside that call. Right? Your program basically stops right here until input becomes available. And if I just run this and I don't do anything, my code's going to sit there forever. It's not taking CPU time, right? It's just kind of hanging out, you know, waiting for input to appear in the pipe. So it's sitting right here. And if I do a PS, which we'll talk about more later, to see what the process state is, here's the program T1 that's running. It's in this state called wait W. It's waiting for input. All right, so it's not going to chew up any CPU time, but eventually it needs something to be input. All right, and one other thing. So I'm calling getchar. If I hit Control D, that indicates end of file. It returns a -1. Now if I say ABC, it gives me the ASCII code for A, the ASCII code for B, the ASCII code for C. Control D is not really magical, right? It's not somehow doing something outside of itself. It's really just telling getchar, hey, return a -1. You can do something with that, you can ignore it. Okay, hopefully you do something with it, because it's meant to say that's the end of the input. But it's really just, it's a trick, right? Control D has an ASCII code of 4, technically. It's the 4th letter of the alphabet. So Control D is not equal to -1. Control D is just a special reserved character that getchar interprets as saying that's the end of the input, and so getchar returns a -1. But on other systems, on DOS or Windows, it's Control Z to signify end of file, right? It's just purely arbitrary. All right, so let's change this. Let's make a loop. So let's call getchar once, and if it's not end of file, let's print out the value of the character, and then let's call getchar again. And this will just keep calling getchar and printing out the values that it reads until we get to end of file. So hello, and I hit an enter, and that's the input. A, B, C, D, E, F, G, H, and so on. And then if I hit Control D, that should kick me out of my while loop. Let's put a message down here. Just to let somebody know that we hit the end. Alright, Control D, and it detects the end of file. Alright, so here's a file. It's got one line in it, says hello. It says 6 characters written. There's a new line at the end, even though we don't see it. So if I run T1 and I say less than file, instead of reading from the keyboard, standard in is now coming from this file. We should have hello followed by a new line. So it prints out HELLO's ASCII codes, 10 is the new line, and then end of file detected. So if you're reading from the keyboard, Control D is how you signal end of file. If you're reading from a file, when there's nothing left in that file, getchar will return EOF. So your code works the same whether you're reading from the keyboard or you're reading from a file or you're reading from anything else. So we can look at our program source code in ASCII. We can take T1 and set standard in to come from T1.C, and that's, you know, the ASCII codes for everything inside my program, ending with a closing curly bracket that's character 125 and a final new line. Alright, so okay with getchar, write some code, play with it, do some experiments like this. It will be your friend for PA4 and other stuff beyond. But it does not come up in the ODP, so this is not related to ODP 419. There's no I/O in 419. All right. Let's talk about super duper getchar. So super duper getchar should be just like getchar but better. So it's going to return an integer, doesn't take any arguments. But what should it do? Let's convert our input into uppercase. So let's return uppercase stuff. We've got 5 minutes. We can do this. So super duper getchar. Alright, so I'm going to prototype this function. Alright, so we want to do getchar, but we want the result to always be uppercase if it's a letter. So let's do something like this. Integer C equals getchar. I don't need to do this, but I'm just going to do this because super duper getchar needs to do 2 things. One, it needs to read a letter using getchar, a character using getchar. And if it's a lowercase letter, we want it to become uppercase. If it's not a lowercase letter, if it's uppercase, if it's a digit, if it's a tilde, we want it to just return the character as usual. But it still needs to understand this idea of EOF. So first thing I'm going to do after I call getchar is say if getchar returned end of file, super duper getchar is also going to return end of file. Okay, so I'm going to do that. Otherwise, what am I going to do? I'm going to check the manual page for toUpper. So the include is ctype.h. Right, so that's got to be included. And then toUpper takes an integer and returns an integer. Okay, the integer is the kind of integer you get back from calling getchar. So if C is lowercase, 2 returns its uppercase equivalent. Otherwise, it just returns C. So that's all we got to do. Okay, now 2 does not modify its argument. 2 takes an integer, and the return value from the function is a new integer, which is the uppercase version. So saying C equals 2 C is the right thing to do here. I could use a different variable instead of C, but there's nothing wrong with C equals 2 C. And then I return that. So if I pass it A, B, C, D, E, lowercase, it gives me back 65, 6, 7, 8, 9. That's the uppercase ASCII codes. If I give it uppercase A, B, C, D, E, it gives me back the ASCII codes for uppercase A, B, C, D, E. If I mix it up with uppercase and lowercase, it still gives me back 65, 6, 7, 8, 9, the uppercase equivalents. Okay, well, let's make this more fun. So instead of printing this out as an integer, let's print it out as a character. So we'll call super-duper getchar, and we'll print out the return value with a %C, which is an integer. Alright, so it's converting everything to uppercase. Control D still hits end of file. So if I do T1 less than T1.C, I got an uppercase version of my source code. It's like shouting at me. Right? So here's a better version of getchar. If you use this, you can completely forget about this requirement on PA4 that all letters should be converted to uppercase. Just call super-duper getchar instead of getchar, and you don't have to worry about that. Now we're going to modify super-duper getchar tomorrow to also take care of white spaces, change them all into a single space, and to ignore those magic characters we want to ignore. And then we got the first 3 requirements bundled into one getchar function. Alright, so think about that, play around with getchar, do 419, and we'll continue with this tomorrow. We still got to go back and talk more about make files also.